Okay, just give me a moment. All right. So today I'll be talking about container escapes. Just a very brief one. I mean, one because this is sort of like a very ad hoc presentation. It's like a very last minute thing. So I just kind of cooked up like a random topic. So this is like a very beginner friendly if you're not familiar with Docker container escapes. So okay, why? So once upon a time, Sakura Nene once said, so what is actually a container? So container is actually just like using a VM. Mhm. So a bit of theory lah. Okay. So what actually is a VM and how it differs from a container? So like on a traditional deployment, like a very old time lah, back in the old days lah. You deploy your application on bare metal. So that's like the one on the left. And then like once they introduce hypervisors, this allow you to like deploy VMs. So a VM is like a container, not a container. It's like a virtual machine. Oh wait, sorry. I mean it stands for virtual machine. What am I talking about? Oh sorry. So it actually emulates like a physical hardware for the virtual machine. So it's like you have another computer inside a computer. So then this so instead of like having separate servers to deploy like one for each application, then you have like a different VMs running on the same machine, but each will be like independent. Okay. Well then like why containers? So containers is like it sort of solves the problem of like let's say you distribute like an application to your friend, right? And then they say, oh, it doesn't work on my machine. But then you tested it on your own machine, and then it works on my side. So it's sort of like not my issue. It's like their issue, right? Okay. So like containers sort of solve these issues, right? So like, they package everything inside of a container. That's why they call it like all the dependencies. So a container, uh, it runs on a shared kernel. So like compared to like a hypervisor, right? It runs the hypervisor is like each virtual machine is like independent from each other. But in like a container, right? Everyone will share the same kernel. So so you can think of like a container as like a processor. So they're on the same kernel. Each of them like a different process, just like any other process on your machine. But then how do they become isolated? So this is done through like Linux namespaces. So the namespace makes it appear like each container is like a separate virtual machine. So that's why normally people say, oh, the container, when I use container, it's just like a VM. It is because of the namespace. It makes it looks like a virtual machine, but actually it's not. Okay. And then back to like shared kernel. So because it's like they're all on the same kernel, right? So they're not really isolated. So let's say you have some kind of kernel vulnerability on the host, right? Or any some kind of misconfiguration that let's say allows you to break out the process or like break out of its namespace. Then that could allow you to interact with the host system. So that's why we call it that's why it's called a container escape. So when we talk about container escapes, mainly there are two types. So the one is like let's say there's like a vulnerability in the container runtime. So let's say your Docker daemon, run C, that's the popular one. Or if there's a vulnerability in the kernel. So then these allow you to break out of the namespace. So like breaking the namespace isolation. So then you can jump to the host. And then the second one is like misconfigure containers. So we'll be talking about the second one because the first one, there's not really much you can do. I mean, if there's like a vulnerability in the runtime in Docker, there's not really much you can do outside of patching it. So you're sort of relying on the vendor in this case. So for today's demo, so for all the examples I'm going to be talking about, we have this sort of like a classic CTS challenge. So our goal is to like read this flag, and this flag is owned by root on my host machine in the /root directory. So then if we are able to escape from from the container, then we will be able to read this flag. Yeah. So the first one, the easiest example of like a container escape is the privileged container. So when you talk about privileged container, for me, it's like a God mode lah. So if you have like this privileged container, you have access to like let's say initial access through a web, and then you manage to jump in land inside a privileged container. You can basically do whatever you want. It's like a God mode lah. So This is done through the dash dash privilege flag. This is on for Docker. Uh, why this is an issue? Because like when you run a container, right, Docker actually comes with a lot of safe defaults. So this is like a very they have like a profile for like the capabilities or like the app profile app armor profiles. So by default, if you don't do anything special with your container, right, it is pretty much safe. It only becomes an issue if you try to do something funny. Okay. So and again, if you are in a privileged container, you are actually root on the host. So for this example, this is the container we're gonna start. So you see here, we first drop all the privileges, not drop privilege, drop all the capabilities. Then we add the dash dash privilege, the flag. Okay, so let me just see if I can play the video. So okay, then sorry, back again. Oops, my bad. So why the dash dash privilege flag, right? So when I first start, I first drop all the capabilities lah. But then if you add the dash dash privilege flag, it sort of adds all the capabilities. So when you add the dash privilege flag, you enable all capabilities. That's one thing. And then the second thing that will be important for the container escape is it disable the app armor profile. So you see in a moment. It's a bit slow. So I start up this container. Oops, my bad. Sorry. So I start this container. Okay. And then because we're the privileged container, you see we have this capability. And then if you try to decode it, decode it, you see a bunch. And then the one we're interested in is the capsys admin capability. So this allows you to run the mount syscall. By default, you can't mount you can use the mount syscall instead of the container. So you need the capsys admin, that's one. And then the second one is you need the app armor profile to be disabled, which we did through the dash dash privilege flag. So if we list like the available disk, you see the def SDA too. And then you notice, right, the size is actually very big. So this is the one on my host machine. So what we'll do is we will mount this inside of the container and then jump into the host machine through there. That's my root, my host machine. And we get our flag. Okay, game over. All right, next. So I talked about privileged containers, right? So it all ties back to capabilities. So, oops, my bad. So what actually is a capability? So capabilities allow you to define what kind of privileges you want to assign to the processor. So the idea is instead of like restricting, let's say you have a use case, right? Use case for your container. Instead of restricting like everything, like making it very hard to use, or the other way is that you grant everything. That's the easy way out. Capabilities allow you to like define, I would say, in a more granular way, what kind of what kind of privileges you want the container to have. So one of it, for example, if you want the container to be able to debug other processes, then that would be like the capsys ptrace one. And there are a lot of capabilities in the kernel, right? I think there are like 40 and more. So yeah, so here are the few ones that the ones common for container escape, like sysadmin, the one we showed just now. And then the ptrace one allows you to debug other process. The ptrace one you also when you debug another process, you can also do like the process injection kind of stuff. Okay. So how you like, let's say you land inside a container, right? How you enumerate capabilities. So if you have cap SH, you can do this, and then you will print all the capabilities. If not, you can read from the proc the status from a process. So normally you read from one, the first process, because that's normally initd, and you get this hex value, and then you can just move it to like another host machine to decode it if you don't have it inside the container. There are like a couple capabilities here. I mean, there's like inherited capabilities, effective capabilities, and what's not. The one we're interested in is the effective one, the cap EFF and the cap AMB. I mean, the effective one, as it says, right, is the effective capabilities that you have at runtime, and then the ambient one is like what kind of capabilities that will persist across like the runs of the processor. Yeah. Okay. So for this example, again, we'll drop all the capabilities. So we'll start from 0, and then we'll add the capsys admin flag. And then to escape the container, we'll have to define this app armor. We'll have to disable app armor. And then I mounted the /dev on my host machine inside the container. So it's actually just the same thing as what we did before, but with extra steps. Okay. So yeah, you need the app armor profile to be disabled to run the mount syscall. So I saw this container, see inside the container. Okay. I enumerate the capabilities. So you have this value. And then if I decode it, you get capsys admin. And then because you know app armor profile is disabled, you can mount the device inside the container. From the host into the container. That's okay, you can mount that and then you can read the flag. Essentially the same thing as the privilege container. Okay, next example. Next example is about sensitive host mounts. As its name says, right? This happens, let's say, if you mount a sensitive directory. Sensitive directory meaning like, let's say it's a privileged directory or like a directory containing some kind of a sensitive file, let's say credential into the container. Then if you jump inside the container, you'll be able to have read or write access to those same files. So normally, let's say for development, right, you mount like a development directory. So then that gets mounted into your container. So if I compromise that container, I'll have the same access to one of the hosts. So like source code or like API keys, that kind of stuff. So in this case, the escape or like privs in this scenario, it sort of depends on what kind of volume is being mounted. So if the mount is sensitive, then yeah, maybe you can escape. So it sort of depends on what's being granted. So essentially you have a read and write access to it. Okay. So this example, this is a very stupid example, you know. So I mounted the root directory on my host to /mount in the container, but just for demo purposes. This is a very bad idea, by the way. Okay. So if we mount this, we mount the root directory inside my host to another directory inside the container, right? Then from inside the container, you have the same read-write access. And in this case, since it's root, you have everything. So you can see the hard disk is mounted in /mount inside the container. Okay. And it's pretty straightforward. You just change directory to that mount, and then you have access to the root directory. Okay. Final one is about Docker sockets. Oh yeah, I think I forgot something. So if you're able to compromise a container and then escape from it, right, you'll be able to you land inside the context of whatever context that's running the Docker daemon. So in this case, normally it's root. But in certain cases, let's say if it's configured if in rootless mode, then maybe it's another service account or service user. But in most cases, you'll be run as a root daemon. Okay. So then that means that if you can escape from that, if you can escape through Docker, you'll be able to achieve root. Okay. So in this example, what I mean by exposed Docker socket, right? It just means that if you're able to interact with the Docker socket from the host inside the container, right? Then you'll be able to spawn malicious containers. So why would someone have to like why would someone mount the Docker socket inside of another container, right? So this is like a very niche use case. Let's say if you want to spawn containers inside of container, then maybe you want to like expose the Docker socket inside lah. So I think this sort of thing may be applicable if, let's say, for CTF platform, right? Normally the platform itself is spun on Docker, and then we want that container to be able to spawn like what's it called, individual instances. Then maybe you have this kind of scenario lah. Okay, so if the socket is mounted inside the container, then you can talk directly to the Docker daemon. And why this is a bad issue is because normally this is unauthenticated. I'm not sure if you can configure authentication, but normally it's unauthenticated. So at that point you just need some way to talk to it lah. So either one is you install the Docker binary inside the container, then you can just run Docker commands, or the other way is you talk to it through the Docker API. So for this example, yeah, I mounted the one on my host to inside the container. Okay, hold on. And I think in this example, I will run it using curl. Yeah. Because normally, if you, let's say you compromise container, right? No, you normally don't expect Docker to be there, but curl is usually available. So let me rewind back a bit. So see the Docker socket is inside the container, and then like you just curl it. So this is running, I think, yeah, all the running containers right now. This is the one running in the challenge. Okay. And yeah, so I wrote this script. What is a lot going on here, but basically it's just talking to the Docker socket. We will spawn a malicious container that will mount the root directory on the host to the mount to /mount inside of that new container. Normally you would run a privileged container, but I think I did this a bit lazy. But if you run a privileged container, it's the same thing. Okay, so now it's just starting, and then once you start the container, then you can just run commands through it lah. In this case, I just read the flag lah. But if you want like root access or anything, I think you can do like reverse shell, yada yada. Okay. Okay. Okay, I think that's it. A very short one. Okay. So sorry, maybe the example is not that good now that I think about it. But if you have any questions, yeah, feel free to ask.